So let's take a look at this one. We're going to throw her straight up, and actually it's always good to sketch a picture. Now there's actually 3 ways I can look at this problem. I can look at it from when I throw her to the peak, that's the top here. I can look at from the peak to when I catch her, or I can look at from when I throw her to when I catch her. So these are 3 separate situations. They are related in some ways, but from the hand to the peak, from the peak to the hand, or from the hand to the hand. Alright, now you can use whichever ones work for you, and usually you don't have to use all 3, you might just use 2. That's what we're going to do today. So I'm going to do it first going from the hand to the peak for the first 2, A and B. So let's set up our givens from the hand to the peak. So these are the standard 5. Hopefully by now you've kind of basically memorized the standard 5. V initial, V final, A, delta, D, and T. So we're just going from the hand to the peak. Do we know any of these? Let's pull out the number first. I did give you a number. What does 5 meters per second refer to? The initial velocity. Good. So 5 meters per second is the initial. So I threw her up, right, with 5 meters per second. So one of the things that confuses people sometimes, if you think about it, before I throw her, what's her velocity? 0, right? So a lot of people will say, oh, isn't the initial velocity 0 because, before I throw her, it's 0. However, if that was the initial velocity, then what would happen to her?
She would go up.
Yeah, the object would just stay in your hand, right? It has to have an initial velocity. So by initial velocity, we don't mean, okay, the velocity down here when I then start throwing it. We mean once she leaves my hand, how fast is she moving? So when I throw it like that, at that moment of leaving my hand, how fast? So what's the answer? 5. Final is 0. Good. So at the peak, right, as she's rising, as she's going up, she's getting slower, 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 and then at the peak, what happens? She stops, changes direction, and comes back down. So at that peak, it's going to be 0. Okay, anything else? Acceleration. What's our acceleration? 9.8. So here's the big question then. Is acceleration positive 9.8 or negative 9.8? Okay, so here's how you want to think. We're going to stick with our standard notation. So when I throw her up, here's where people always get confused. When I throw her up, obviously there's an acceleration to get her moving in the first place. However, that's not what we're talking about. We're talking about once she leaves my hand. So once she leaves my hand, her velocity's up. What's true about the acceleration? It's down. Okay? So her velocity is up, her acceleration is down. And what happens to her on the way up? She slows down, right? So this should be a negative acceleration on the way up.
I get it now.
Okay? So velocity's up, acceleration is down. That's why it's going to be negative. Notice in the previous problem, what direction was the acceleration? Wasn't the opposite. What direction was the acceleration? Down. And what was the sign? Negative. Yeah, so it was negative in both cases. The acceleration of gravity is always pointing in what direction? Down. Okay, it's always pointing down. What about at the peak, though? When I throw him up, what's the acceleration at the peak? If it was 0, what would happen to him? He would just levitate, right? I would throw him up, he would go up, and then at the peak he would just levitate because zero acceleration, right, and zero velocity. However, what does he do? Comes back down. So gravity does not disappear when I throw him up in the air, right? Right at the peak, all of a sudden gravity doesn't disappear. It's always down, and if you always keep it negative, negative 9.8, it's always towards the Earth, you'll be good. All right, let's keep going. How high does she go? So we now have our three things. Can we go ahead and find the fourth and fifth? Which one's going to work for us here? We're looking for distance. Yeah. So fourth one looks good. VF squared. Zero equals 5 squared plus 2 negative 9.8 delta D. We get negative 25 divided by 2, negative 9.8. Again, if you didn't make it negative, you would just end up with a negative displacement. So what's that, about 1.25? One point what? 2.8. Okay, so that would be our delta D, 1.28. That's the height, the maximum height that we reach. Remember, this is hand to peak. Okay, ask for one more thing. What was that? How long? How much time? Choose an equation for that. Let's try to do it without delta D. First one. VF equals V initial plus AT. VF is 0, V initial is 5. It's like about a half a second. 5.1. Okay, 0.51 seconds. Looks good. All right, let's keep going. So letter C. How fast is she moving when I catch her? All right, for this one, we're going to set up a new set of givens. And actually, you have your choice. You can go from the peak back to the hand, or you can go from the hand to the hand. Both ways will work, so it's kind of up to you how you want to do it. I'm going to do hand to hand, but maybe in a future problem we'll do peak to hand. So some of the givens will be the same, some of the givens will be different. For example, what's true about V initial? Still 5, right? Okay. What's true about the acceleration? Did you guys say negative 9.8? So the acceleration is negative 9.8, and again, on the way up, it's slowing it down. The acceleration's this way. On the way down, it's speeding it up, and the acceleration is still this way. So in one case, remember, negative acceleration does not mean necessarily slowing down. On the way up, it's slowing down. On the way down, it's speeding it up. And then what's it doing at the peak? Changing direction. Yeah, so at the peak, it's changing its direction. So it's doing all three things that acceleration can do in the course of this problem. Is final velocity 0? Okay, this is another one of those, when I catch her, her velocity is 0, but that's not what I mean. I mean right before I catch her. So we need one more. I'm going to bring the problem back up. Key phrase is this: catch her at the same height. What does that mean? Displacement is what? That's a great point. Is displacement 1.28 times 2? Is it 2.56? No. Okay, the distance is 2.56. What is the displacement? 0. Good. Why is the displacement 0? Okay, remember, displacement is how far from where you started. So I started at the hand, I caught her at the hand. That means that there's no change, right? We're at the same place, exactly where we started. So those are our 3 givens. What did I ask you for? Final velocity? So look at your list, find the one that works for you here. So basically you want the one without time. Which one's missing time? 4th one? So this is going to be pretty easy right here, right? Vf squared equals 5 squared plus 2 times negative 9/8. But what was d? Delta d? 0. So what is Vf? You're going to square root of 5 squared, right? Square root of 5 squared is simply 5. Actually, it's not 5. What is it? Plus or minus 5, right? That's the true mathematical solution. What's the right answer? Negative 5. Good. So this result actually should maybe be a head scratcher, at least at first. What's true about what do you notice about that number? It's the same as the V initial, yeah, and this will always happen. When you catch it at the same height, or when it lands at the same height, the V initial and the V final will be the same, just in opposite directions, okay? So this V initial is 5, this V final is negative 5, yeah.
But that's also
Assuming
assuming constant acceleration, right?
constant acceleration, right. So gravity is going to be constant close to the surface of Earth. So this is going to be negative 5 here. You can use that for future problems. So in a future problem, you can know if it's at the same height, the VI and the VF will be the same. All right? This is why you don't shoot guns straight up. You shouldn't shoot guns at all, but why don't you shoot guns straight up?
Because they're going to come back down and hit someone.
Okay? Not only are you going to come back down and hit someone, but how fast should they move on the way down? It's the same speed. Yeah, you would never do this, right? Clearly. So same thing. It'd be traveling at essentially the same speed. All right, so that's letter C, right? One more to go. Letter D. Why don't you see if you can do D on your own? And once you solve the answer, I want you to look at that number and see if you notice anything special. What are you guys using? 1, 2, 3, 4? 3? So let's just remind ourselves how we do the algebra on this problem. You have to factor out a t. Let's just do the math here. Negative 4.9 t. So how many solutions do we have? 2 solutions, right? So whenever you have this, you actually have 2 solutions. Solution number 1, the easy one, is what? T equals 0. Okay? T equals 0. And then, or this equals 0. So 5 plus negative 4.9 t equals 0. So either t equals 0 or this equals 0. So that is about 1.02. So either t equals 0 or t equals 1.02. So again, in physics, we often get two solutions. You have to figure out what the right one is. What's the right one? T equals 1.02. Now this one, the reason why you get two answers is you're basically saying, when is Barbie in my hand? And she's in your hand 2 times, right? The first time is before I throw her at t equals 0, and then I throw her up and I catch her and she's in it 1 second later. So that's why you get two solutions. Now what's the one that we're looking for? 1.02. So I asked you guys to think about this number. What do you notice about this number? This is exactly double the time to the peak. So 1.02, the total time in the air, is exactly double the time to the peak. You can use this on future problems as well. Now this is only true under these conditions, if it's caught at the same height. So if you throw it and catch it higher, it doesn't apply. Or you catch it lower, it doesn't apply. Only if you catch it at the same exact height. All right? What about the time from the peak to the catch? Same as the time up, right? So the peak to the catch would be the same as the time.